Okay, so the other day we talked about the commutative property, where you can move numbers around. So if you have something like 35 plus 199 and maybe 65, and you don't really like the order, because order of operations, you'd have to go left to right with adding and subtracting. But you're like, well, I really want to take this 65 and put it with that 35 to make 100, and then add 199, because I know I can do that mentally. If you're moving something, it is the commutative property, because you are commuting. It's not the commutative property. There's no wine or grape juice taking place. Nothing to do with communing, or communion, but commute. So another property is the associative property, and on page 198, you can kind of look above there and it describes what it is. But the name means what it is. It's associative. So if in high school your parents are like, I don't really like who you're associating with, it means they don't really like your group. So this deals with how things are grouped. Now, nothing can move. So if things move, it's commutative. Associative deals with grouping. So for example, say I have, I don't know why that appeared, but say I have something like 65 plus, and then I have my 35 there, and then plus 197 or something like that. Order of op says you have to do parentheses first. And so basically, properties are kind of like rule breakers. They're like, well, if this happens, then you can bypass the rule. So it's all adding. So instead, I could group these together. Instead, I could say I'm going to group these. Now, I'm not moving the numbers around. I'm just grouping them different. So I'm putting these together. These two are going to associate together instead of these two. So then I can get my answer easier. So if you have the commutative property or associative property, you can kind of bypass a little bit of order of operations. Again, they only work with adding and multiplying. They do not work with subtraction or division. All right, so it says use this stated property to rewrite to make it easier. So pause, do number 4, try to rewrite it. Here, only using associative, which deals with grouping, only do associative, and here do both, commutative and associative. So I'm going to pause, you give those a try. Okay, so associative means I'm just going to group it differently. So I'm not going to move numbers around, so I'm going to keep these in the same order. I'm just going to group these. And the reason that makes life easier is I can add 30 plus 68 mentally and get 98. Same thing here, only deal with grouping. So I can't move the numbers, but I know 15 times 2 is 30. So then that makes that a little easier to get 240. Here I'm going to move them and group them. So 72 doesn't add super nice with either, but 11 and 19 do. So I'm going to move the 11, which is commutative, and I'm going to group it. So then I'm going to get my 30, adding to 72, I get 102, which is nice. All right, so read the directions to this next part, and we've kind of done this already. Actually, adding and subtracting is just like collecting like terms. So it's really no different, just cats with cats, dogs with dogs, x's with x's, x squareds with x squared. So you've kind of already actually learned that already. But give it a try, see what you get, and I'll come back in just a little bit. Okay, so cats and cats, dogs and dogs. So I have 3x squared and 4x squared, so I have 7x squared. Again, I'm just counting so shapes don't change. Negative 5x and negative 7x is what? A negative 12x. And 6 and a negative 5 is plus 1. And again, some of you are like, why aren't the powers changing? Well, because when I have 3x squared times 4x squared, then I am creating volume or area. And so then, yeah, I multiply and I get new shapes because I'm creating something new. Kind of like with fractions, when you multiply, you get a new shape, a new denominator. So you're creating something new. When you're adding, you're just counting. So like 3x and 4x just give me 7x's. Or if I have 4/5 and 3/5, I get 7/5. I'm not creating a new unit. I'm just counting the unit I have. So power should not change when you add. All right, let's try the next one here. What do I have? I have 7y squared. I have a positive 5y and a negative 8y. So what I owe 3y, negative 14, and I can't see. Is that a positive? Yep, that's positive. So let's see, positive 3 and what? A negative 14, so that's what? Negative 11. So negative 11. All right, and again, we tend to write them in descending order, meaning the highest power first all the way down to the constant. And then here I have 9x squared minus 4x squared, so that's what? 5x squared. And then I have 6x and then plus 15. So adding is just like collecting like terms. Subtraction, we got to be a little trickier, but we'll do that here in the next section. So why don't you pause, turn the page, a few pages to get to the next section, which is the distributive property. Okay, we're on page 202, and so I want you to go ahead and crunch the numbers for number 1. So try it both ways, see what you think. Is it going to be the same? Is it going to be different? And then we'll talk about why. So I'm going to pause, and again, you need to do the math here. Okay, so remember, to use a percent, you always multiply it. And you could do 8%, like multiply by 0.08, and then add it to the price all the time over and over. But remember, it's faster to use a multiplier, so like 108%. So, because that gives you the 8% tax, and it adds it to the price, so you don't have to do 2 steps. So, let's look at the first scenario. So, the first scenario is that they're going to get the total. So, they're going to get the subtotal of adding everything together, like at Target or wherever you're at, Kohl's, and then they're going to do tax on that total. So we got that situation going on over here. The other option is that they could tax each item individually. So like this is the price with tax, this is the price with tax, and then this is the price with tax. And then I can total that up. Okay, but again, to use a percent, you always multiply, and I'm using 108%. Because I want all of it plus the tax. So I want all of the price of the item with the tax built in. So if you do it either way, you're going to actually get 122.04. So it won't matter. The price is going to be the same either way. All right. And so today we're going to talk about the distributive property. So if you look at this, I can distribute that tax to this guy, distribute it to this guy, and distribute it to that guy. And the price is going to be the same either way, whether you do it individually and total at the end, or do the total first and then do it. Mathematically, it will be the same. And so I want to kind of maybe draw a visual to help you with this a little bit. So if you think of real life, like say I have a car and I have 2 people sitting in the back, or front, and 3 in the back, and say I have another car with 2 in the front, 3 in the back, another car with 2 and 3, and then maybe 1 more. Okay, so mathematically, I have 4 sets of 2 plus 3. And this is the front seat people, and this is the back seat people. Okay, but I have 4 groups of them, or 4 cars. All right, so if you think mathematically, I can distribute that. So I can take it this and this. So what does that mean? Well, if I do that, I get 4 times 2 plus 4 times 3. So what math is that? Well, that means 4 sets of 2. So what that is those are all the front seat people. So I have 4 groups of front seat people. And then this means I have 4 groups of back seat people. And so mathematically, I can total up the cars and multiply by 4, or I can do front seat and back seat. So the math has to be the same. So let's do order of op. Order of op, please excuse my dearance, I have to do parentheses first. So that would be what? 4 times 5. And what I'm doing there is I'm totaling the car. So 5 is the total number of people in the car, which 4 times 5 is 20 people. All right. Now, if you look over here, 4 times 2 is 8. And that would be all of my front seat people. Plus 4 times 3 is 12. That's my back seat people. So when I do order of op over here, what I'm doing is getting a total per car and then multiplying by 4 cars. Here I'm focusing on front seat and back seat. But notice what's 8 plus 12? Still 20. So the distributive property works, and it has a really long name. It is the distributive property of multiplication over addition. So I'm taking this multiplication, like the 3, and I'm distributing it over addition. So I'm going to multiply 3 times x, 3 times 2 is 6, over addition. So it's the only property that actually has both multiplication and addition mixed together. Right? And it is called the distributive property. So why don't you look at the top of page 203, maybe read that a little bit, and try doing problems number 2. And try, let's see, why don't you try A through C to start out with. So try those, pause, try those on the next page, and then we'll catch up together. So again, hopefully you tried these on your own. We're going to distribute this over. So negative 3 times that is a negative 3x squared. Negative 3 times that is a positive, what is that, 12x. And a negative 3 times that is a negative 3. Now notice if I had 3 things to begin with here, when I distribute, I'm still going to have 3 things because I'm distributing it to each deal. Now here, that negative or that opposite is going to go through. So the opposite of a negative 4 is a positive 4. The opposite of a negative 7 is a positive 7. And technically that equals 11. Here, I'm going to multiply this times all 3. Now notice I have an x in there, so powers are going to change because remember when you multiply, you are creating a new object. But when you add, you are not. So let's see. Let me erase my writing there so we can see what we're doing. All right, so I have 10x times that is going to be 10x cubed. I'm creating something new. That negative goes with that. So negative 50, and again, creating something new. And then 10x times that is what? 60x. These cannot add together because they're not like dog or like terms, cats and dogs. So like this is a cube shape. That's x by x by x, but this is only a square shape. That's x by x. So even though they have x's in them, they're not the same. Now, go ahead and try D, E, and F, and I'll come back and do those with you. Okay, so this one, the 2's after the fact, but you can still distribute multiplication over addition. So I get what? 16 plus 2x. Again, a lot of times we write it like this just to put the highest power first and then constants last. But again, if my math lab doesn't tell you to do it, don't worry about it. All right, here I have to distribute that. So I get what? 12 minus 8i. And then distribute that, and I get what? Plus 48 minus 6i. Now, then at this point, I can collect like terms. So it's kind of like I have 2 problems over here, like this and this. Kind of like an order of operations problem. And now I can combine them. So cats and cats, dogs and dogs. Constants with constants, variables with variables. So 12 and 48 make 60. And then debt and debt makes more debt. And, oh, that's an I. All right, and usually we write these in this order because technically that's imaginary numbers, and so that's kind of how they typically write, like a real part and an imaginary part. But, all right, let's distribute this again. See how there's an x in it? And I have 3 things here, so I'm going to get 3 things in my answer, but powers are going to change. So 12x, creating something new, so x to the 4th. Minus 8, because 2 times negative 4 is negative 8, and then creating something new. X and x makes x squared. And then 2x and 11 is plus 22x. All right, now over here, that negative goes with that when you distribute. So negative 5x, negative 45. So again, this is kind of an order of op problem. We have some math to do over here. We have some math to do over here. But then now we have addition, so we need to combine them. So look to see if anything's like term. I don't see any more of those, so that's by itself. I don't see any more of those guys, so it's by itself. But notice these are like terms. They're both x's. So if I have 22 x's, if I could draw them, but then I owe 5 x's of debt, and I kind of want to know how many x's I have total. So 22 minus 5 is what, 17? And so those are like terms. I can combine them, and then the minus 45 stays there. One thing you need to be super careful of is if I give you something like this. Addition, you can just combine like terms, but if you have a negative there, you need to distribute that because you're subtracting all of that. You're subtracting this and you're subtracting that. So I always kind of think it's a good idea to add the opposite and make that negative and make that. So you're distributing that negative to both. Then notice x and a negative x or x and the opposite x cancel or simplify. They equal 0. And then here, actually 3 and a negative 3, they also equal 0. So the answer to that is 0. All right, why don't you flip to number 3 on the next page and see if you can write that, and then we'll go there next. So try number 3 on the next page. Okay, so a lot of people that are good at mental math, they use a distributive property a lot. So you don't really want to take this times this, this times this, this times this, this times this, and, you know, put all your zeros and all that jazz. So instead, you can break 11 especially into 10 plus 1, but even 12 you could do 10 and 2. And the reason this is nice is most of us like to multiply by 10. So if I distribute, I get 170. And then if I distribute, I just get 17. And so I can kind of add that mentally. Right? And notice that's what you get when you do the standard algorithm. 1 times 7 is 7. 1 times 1 is 17. That's your 17. That's this part. And then you come over here. This really isn't a 1. It's a 10. Right? When you take 17 times 11, this is really in the 10 spot. So this is your 10 times 7 and 10 times 10, and which gives you 170. So